Hi, welcome to the Intermediate to Advanced Linux series from CBT Nuggets. In this series, we're going to expand on what we did in the Introductory Linux series. So you should have either worked through that material or be sufficiently experienced with Linux in some other way. Now, I'm still going to explain all of the material in this series in a comprehensive way. I'm just not going to walk you through all of the preliminaries for topics that we covered in the last series. In this series, we're focusing specifically on Red Hat Linux to help prepare you for the RHCE exam, the Red Hat Certified Engineer exam. This is currently the most comprehensive and practical Linux certification out there. And working all Red Hat Linux on hardware that's been certified, then Red Hat will give you support, a good deal of support, because they believe that this hardware and software should work perfectly together. Okay, so again, this is certified hardware. If you need Red Hat Linux 9 hardware, you need to click here. Okay, so certified hardware, we're going to click on that, and what it does is it says choose a manufacturer, and you can see here all the various manufacturers that are out there. Okay, let's just pick Dell and see what they say about Dell. And then there's some subcategories: desktop, workstation, laptop, server, and so on. We'll just click workstation over here. And now it lists different Dell computers and the versions of Red Hat Linux that they've been certified to work on. So here, just take this one. The Precision 420 has been certified to work on Red Hat Linux 6.2. If you scroll down this list, you'll see newer versions of Linux over there on the right. If we go all the way down to the bottom, you'll see here's the Optiplex GX260. And that has been certified to work on Red Hat Linux 8.0. Okay, so if you're running this version, if you're installing this version of Linux on the corresponding machine that's over here on the left, then Red Hat supports that setup, and they will give you support if you're having problems installing or running this version of Linux on the various machines on the left. Okay, now let's go back a couple levels and look at, instead of just looking at certified hardware, let's look at the complete listings of all hardware listings for Red Hat Linux. Okay, again, it's going to give us a list to choose from, but now this list is way longer. Okay, because this is all the hardware for Red Hat Linux, not just the hardware that's been certified and guaranteed to work. Okay, let's just pick one in here. Let's pick NVIDIA. I have an NVIDIA graphics card, so we can see what that says about. Okay, so here it says please select the hardware category for NVIDIA. There's only one choice, the video device controller. So I'll pick that, and now again it's going to list various different NVIDIA graphics cards and different versions of Linux, and saying whether they work on that version of Linux. Okay, so there's different grades here. There's this green check mark and there's this yellow question mark. And then on the last screen, when we were talking about Dell workstations, the little picture here was the guy in the red hat, and it was said it was not just compatible, it said it was certified or Red Hat ready. Okay, and so the compatible means Red Hat's looked at it, but they're not guaranteeing that it'll work. They'll still offer support for it, but they haven't put it through those rigorous tests to say that it's Red Hat ready. So you can see here it says NVIDIA Various. So if you click on Various, it'll tell you which actual video cards it's talking about. It's talking about, you know, all these video cards, the GeForce, GeForce DDR, GeForce 2, and so on. Okay, and then it's saying where's the driver location. Well, it's on the installation CD, so you shouldn't have any problems there. If you pick this video card during installation, it'll have the driver for you. And then the ease of installation out here is the little pointer is on green all the way out to the right, which means it's really, really easy. Okay, so this is like 5 grades, 0, 1, 2, 3, and 4. Okay, and each of those grades, as it goes to the right, gets easier and easier to install. If it's all the way over here on the left, that means it's really hard to install. You're going to have to, you know, modify source code or something to get it to work. Okay, so again, let's back up and look at more NVIDIA graphics cards. Again, as you scroll down this list, you'll see newer versions of Red Hat Linux down memory where it's going to go and read this information from. Okay, so the device driver here says, hey, there's something out there in memory for the printer to print. The printer goes and takes care of it on itself. Meanwhile, the CPU is left free to do whatever it's got to do. Okay, and the last one here is a direct memory access channel. So this is another kind of way that devices communicate in an Intel system. Now for this one, let's talk about a sound card out here. Okay, so here's my sound card, and over here are my speakers. Okay, so if I have some file on disk, some song that I want to play, then what I can do is, because my sound card has its own little processor, the sound card can set up a direct memory access channel and bypass the CPU altogether. Okay, so the disk can transfer to the sound card, and the sound cards can then play it out of my speakers, and the CPU is out of the loop. So that's good, because then the CPU is left to free to do whatever it's got to do otherwise, and the sound card can take care of the processing required to translate, that MP3 or whatever file is on your disk into the format that the speakers can understand. Okay, so that's what the sound card does, and it takes care of all that processing and leaves the CPU free to do other stuff. Okay, so there's a very basic overview of how communications channels work in the Intel architecture. Now let's move back out to the Linux screen and talk a little bit more about interrupt request ports, and so you can see which devices are assigned to which ones. So let's look at the IRQs that are already in use on this system, and the way that we can do that is we go to the proc/interrupts file and we print that out to the screen. Okay, so there are 16 IRQ numbers ranging from 0 to 15. All right, and you can see here by just looking down this list that not all of them are in use. First, let's talk about the ones on my system that are in use, what they interpret to, and then we'll talk about the ones that are free and typically where devices get assigned to IRQs, and then we'll talk about what to do if you are run out of them and you try to add some device. Okay, so make sure, though, first is that you make sure that you're not conflicting with an IRQ that's already in use, because if two interrupts can come on the same channel, then your system can hang, because the CPU doesn't know which device is hooked up to that channel that it needs to service. Okay, so that would be a problem if you assign two devices to the same IRQ, and to double check, just look at the proc interrupts file to make sure you're not doing that. So you're running out of IRQs and you need some more devices on your system? Well, usually this isn't a problem, because the kinds of devices that you're going to add to your system are probably either PCI devices or USB devices. Now, PCI device, if you have a PCI slot open in your motherboard, you can plug a device in there and it can share the same IRQ as all the other PCI devices. And this is because the PCI bus manages the way that each PCI device shares the IRQs. So there's the PCI bus is like a higher level manager to these IRQs for the PCI devices. Same goes for the Universal Serial Bus Controller. The USB controller governs the way USB devices and how they share IRQs. Okay, so again, these two devices, if you're adding one of these two kinds of devices to your system, it's not a problem if you're running out of IRQs, because the individual controllers will take care of how they manage the IRQs. Now, if for some reason you need to add like 10 serial devices to your system, you're going to run into problems because there just aren't enough IRQs to do that. So see if you can convert or find similar devices that either use the PCI or the USB interface, and then then you can use those devices in that interface instead of the regular old serial interface. Okay, if all else fails, I guess you'll have to go to Device Addicts Anonymous, because you have too many devices on your system. Okay, so for me, this has never been an issue. I've never run out of IRQs on a personal computer of mine. I'm not the kind of person that hooks up like 97 different things to my computer, but if you are that kind of person, then look into USB and PCI devices, because that's going to make your life easier. You're not going to run out of IRQs in those instances. Alright, so now let's move on and talk about disk partitioning for a little while. We should already have an idea of what a partition is. Okay, this is true in every Linux system. The first IDE hard disk has a label A on the end of that. HDA is the first one, HDB is the second IDE disk, HDC is the third one, and SCSI disks are similar. SDA, BC are the first, second, and third disks respectively. After the first three letters, there's a number representing the partition number. So HDA1 would be the first partition on the first IDE disk. HDA2 would be the second partition on the first IDE disk. Okay, again, the same for SCSI disks. So up here, the numbering for this scheme would be this one would be 1, say this one's 2, this one's partition 3. The extended partition would be partition 4, and then the logical partitions inside would be 5, 6, and 7. Okay, now partition 4, you can't really write data to partition 4. Partition 4 is this extended partition that just keeps track of these logical partitions inside of it. So you could never write data to like HDA4, for instance, in this example, because HDA4 isn't really a partition. It's just an extended partition that holds these logical partitions. Okay, and here's another thing to note, is that logical partitions will always, the first logical partition will always be numbered 5. Now that seems to make perfect sense, right? 3 primary partitions, the extended partition is 4, and so sure, the first logical partition is number 5. However, it's always going to be labeled 5 even in this scenario over here. Okay, so say I do this. Say I make a primary partition, I make another primary partition, and then say I make the rest an extended partition, and I stick 4 partitions in there. So this disk has 6 partitions, just like this disk has 6 partitions. Okay, now over here though, the numbering is going to be like this: 1, 2, 3 for the extended partition, and then 5, 6, 7, 8. So there's no partition 4. And there's no real problem with that. Some people do find that a little bit confusing, but this can lead to problems later, so don't do this. If you need more than 4 partitions on your system, follow this scheme over here of where you label it 3 primary partitions, 1 extended partition, then however many logical partitions you need inside of that. And remember, the number of logical partitions you can stick inside there depends on what kind of disk you have. If you have an IDE disk, you can have a total of 63 partitions on your disk, and for SCSI disks, we have a total of 15 total partitions, and here I've listed out the labels for the logical partitions on each of these disks. Alright, well, it's time to wrap up our first video. We talked about hardware requirements, like how much RAM and disk space we need to run Linux. We talked about hardware compatibility and how to use the Red Hat hardware compatibility list on the website. We talked about communications channels and IRQ ports and direct memory access and that sort of stuff. And then we started our discussion of disk partitions, and this is going to continue on into the next video. In that video, we'll talk about the tools that we use to partition disks, and we'll walk through a couple case examples of what a good partitioning scheme might be. Alright, well, I hope you found this nugget informative, and thanks for viewing.